Hello all and welcome to this project. In this project, I'm going to use SQL to answer some of the most difficult questions that you can find in every single company. In this video, I'm not going to just run the simple select from a query from the SQL, which you can find everywhere. I'm going to show you how you can use some of the most difficult queries in SQL, and all of them, before writing the code, needs thinking about it. I mean, if you don't know what you're going to answer, it doesn't matter which tools or techniques or query you are running. So these questions need a bit sophisticated techniques in SQL, and I hope we will have a wonderful journey in this project. Before further ado, let's see the EDR or entity diagram relationship for this project. You can see we have 6 different tables and the relationship between them. We have the employer, we have the department manager, we have department employer, which is the helper table, we have salary, and we have the title or the job positions. Employer table just shows the basic information about all employers in the company. Department manager shows only those employers have at least one managerial position in the company. And department shows just the basic information about different departments in the company. Department employer is just a combination between the department and employer. It shows which department one employer is working or more than one. Salary makes sense. It is just the information about the salary during the history. For example, if an employer worked on different departments, for every single time, for every different departments she has worked, we can find the salary. And title is the same as the salary, just shows the title and positions. So we can start the project and answer some of the most difficult questions. Okay, now let's see the first question. The first question is asking, find the name of departments where a manager has never worked in there. At the first glance, this question might be simple, but it's not easy. We should find the departments that one manager has never worked on. I mean, it is the opposite side of inner join. The opposite side of inner join is cross join. Cross join means if we have 2 tables, we can multiply each row together. For example, if table number 1 has 10 rows, table number 2 has 20 rows. After that, we will have 200 rows. We should multiply the rows together. So in that case, we will have the reference table. Let's do that. Before going to the query, let's see the entity diagram. Okay, this is the entity diagram that we have. We're going to work on 2 tables, the department manager and the departments. We should find the name of the departments where the manager has never worked on that. So I go on the query. Okay, first of all, let me select everything from department manager. Okay, this is everything from the department manager. We have a list of all managers. Now, if I go just with the simple join or inner join, I can say inner join with the department name. You see, if I go there, the department manager with the department. So, sorry, I should go with the department. Okay, and what's the key? The key is department name. So department number is department number. This one is D, this one is department manager. Just join the 2 table. Okay, I'm going to select everything from department manager and department. Let's see the result. What's wrong? I forgot on. That's fine. Okay, now let's see the result. We have just the inner join. We have the common rows. For example, if we have the employee number, such as this manager has worked on this department, or this manager has worked on this department. If it's order by employer number, which is coming from department manager. Let's see, for example, this manager has worked on this department and no other department. The question is asking which department has never worked. So inner join doesn't work for us. We should select the opposite way. The opposite way is cross join. And as I said, the cross join just multiply number of the rows from different tables together, regardless they are in a common rows or not. So instead of inner, I go with cross join, and cross join doesn't need on because it doesn't follow the relationship between the table. It multiply the rows together. So now you see for employer number 110022, we have list of all departments. Let's see here. I go for department number to see everything in a sort. Department number, it's coming from this employer. If I select it just a bit, you see we have all the rows for this employer number. We have all the departments. Now we are pretty close to answer the question. Which department this employer is working based on the DM table? Department number 1. But here we have not only department number 1, we have list of all department. Why? Because we used cross join. So we only need to filter out the common one, filter out the inner one. How we can do that? We can say where, what is the key? Department number, and the other one, department number. The key is that they shouldn't be the same this way. If I say this ID shouldn't be the same with that ID, otherwise, show me everything. So I just select it. Oh, I forgot to put that on. I don't know why I forgot to put the aliens. Okay, now for for employer, we don't have department number 1 here. Why? Because she's working in department number 1. We are looking for which department she has never worked. So just the last step, we only need employer number, a name of the department, or department name, which is coming from the department. That's it, and filter. This manager has never ever worked on this department, or this manager has never ever worked on this department. You see, with cross join, we can simply answer this question. Okay, let's go to the second question. Second question is asking combine employee career events into a single analytical dataset showing in which dates that employee changed the title and the department. Let me break down the question. It says we need a table for analytical purposes. Maybe the data team needs it or the marketing team needs it. That's fine. We need to write a query to fetch the data as a table. This table should show the list of the employer and one column as the date and the other column just as a label. Which one the staff changed, the title or the department. With this table, we can understand in which date the staff or the employee had a change on the title or in the department. If I show just the EDR, we need to work on 3 tables: employees, title, and department. But just because we need just the information about the titles and the department, as the question is asking, just a change in department and titles, we don't need the employees table, just 2 tables, title and department. Let's start with the title first. Okay, I need to select everything from title. Let's see what we have this table. We have employer number, we have title, we have from date and to date. Just because we are only looking for the time that the change happened, we need only from date and not to date. So I only say I need the employer number and just from date. Only these two. This is the time that one thing happened for changing. So I need to add one more column. I need to add, for example, let's say uh, this is the title. We can say title changed. That's it. Just run it. One more column, and the value is the same for all of them because this is exact time or the date that the staff had made a decision to change the title or they change the department or anything. Now we need to have the same pattern for the other table. The other table, if I go to the EDR, is department employer. This table is just capturing all the information about which department, which staff was working. So I only need to copy, go there. So what we need employer number that we have from date that we have. The only change is it should be department employee table, and I can say department changes and just run it. Yes, and this is the result. We have the other table. Now we have two tables. If I run it, we see all the information from the title. If I run it, we see all the information from the department. But the question is asking, we need to combine events. So somehow we need to put together these two tables. We can use the union. If I go with the union, we can union these two tables together. So I only need to remove that one and union all. We need to have not as a title change. We should have a column that combines the conceptually the same. So I need to just put the alias as, for example, event type, and I can copy exact for this one. Now I can run it, and this is the event type. So for this employer number, you see this employer number on 26th of June, the title changed and the department changed. For this employer on this date. And it makes sense. Oh, for example, this employer, you see, 3 times in different years, she made the decision to title change. The first one was 18th of February. She decided to change the title. Then 5 years later, in one day, she decided to change title twice. So we can put this table as a subquery. For example, if I can put all this table, for example, as my table, just in case, and I can say select everything from as. That's it. Now I can run it to see the result. We put all of them as a subquery. I can close it. And now I can order by based on employer number. That's it. This is the result for something that different departments in our company needed. I can say writing a query for these kind of questions is not difficult. You see, we just have 10 lines of the code, but understanding the concept before writing the query is very important. Okay, let's see what is the next question. The next question is asking how many salary contracts signed by female employees have been valued or their salary is above the all-time average salary value in the company. It means for asking this question, we need a reference number. That reference number is the average of salary across the company. We need another data, which is the salary for the female, and we need to compare this number with that reference. After that, we should filter the salary for the female based on this metric or measure, and then we should find number of the rows. So the first step, if I show the EDR, the first step is just find the average salary across the company. We need the employer number or everything about the salary table. So I go for select everything from salaries. Let's see the table. We have all information about the salary. Which kind of information we need? We only need average salary. So I say average salary. That's it. This is the only thing we needed. This is average salary. I call it the alias average salary. Okay, this is a number that we are going to use. Later, we need the salary or we need the information about all female employees. This data is coming from the employees table. So let me first bring everything from employees. This is all information about the employees. Okay, now I'm going to bring the salary because we just have the information about the employees. We need their salary. So if I come back to the EDR, we need to join the employee table and salary table based on employer number. So I go for join salaries on employer number equal employer number. The salary I alias as a S, employee I alias as a E. And let's bring everything. Okay, we have all information, but we need only focus on some columns and not all of them. For this section, which is from the employees, I only need to focus on gender, which is coming from employee. The next one is only the salary. So salary is coming from salary. Oh, salary. This is the only columns that they need. Only female and salary. I need one more column as an employer number because I need to see the information about employer number and it should be from salary because we are going to find number of the contract and contract is registered in a salary table. Okay, we have employer number, we have salary, and we have gender. I would like to just switch first employment number, gender, salary. Okay, but I need to bring one more column. This column should be the average across the all people or employees in a company. Also, as you can see here, I have gender male and female. I have not yet filtered the data. I just brought everything. Before bringing that column, let me filter the data and it should be gender, should be female. Now we only brought the female, their salary, and the employer ID. Now it's time to bring that column. That column, I'm talking about this column. We're going to add a column as the average salary here. But this number is stored in different tables. This number is here. And we need to bring that data as one column here. How we can do that? Definitely with CTE. I go here and say with, I would like to put as an average number as, I put all of them here. This is the city. If I just select everything from average salary, if I select only this section, you see the average salary here. So we put all the average salary, one number here. So I only need to just bring one more column here just because this number should go for every single row we need to use cross join. Cross joins means cross or multiple that number or that columns or rows for every single rows of the reference table. So I go for cross join, and that cross join should be based on this table. I would like to put as an average salary, or let's say ABGS. It is just an alias for the name. Cross join with this column. Now, if I select everything, okay, we need to have one more column here. And what's the name of that column? It is, oops, this one. This is here, and the alias of this column. Now I select everything and run it. You see, now we have one more column as an average salary, which is coming from the CTE. And this is the same for all rows. Why? Because we used cross join. Now we only need to add one condition. The condition, if I let's put it there, I would like to let me make it a bit beautify. Okay, I would like to put just a bit beautified everything. Okay. Now I would like to say one condition, case, and as, for example, I can say, and as it is female above salary. This is just name of the column. Case when the salary, which is this value, when the salary is more than the average salary, then 1, else 0. And put name of the column as a female above salary. Again, I select everything. Why I need to select everything? Because I need to select CT also. I select everything. Now we will have one more column as a female above salary. You see we have 1 or 0. Now the only thing we need is just count number of the rows. Okay, now I would like to put everything as a view, and after that just work with this table as many as time I need it, because this is a table that people might need it in a company. So I go above the table and I say create view, and just put a name, for example, table female salary as, and the rest of the code are here. I select everything and just run it. If I go to the view, just refresh. If I go to the view, you see we have one more column. I go here and say select everything from this view. Just say what we have. We have that information. The easiest part is here. Select count of employment number from the table where female above the salary is 1. That's it. If we run it, this is the result. Overall, we have 171,194 contract. It's not number of the staff, it's number of the contract. Maybe one staff has more than one contract. It is number of the contract only for female that the salary which is contracted is above the average salary of the company. Okay, let's go to the next question. Next question is a bit more advanced. Next question is the HR analytics team would like us to write some kind of application to help them to identify employees within a specific demographic group. And one more condition is that that application should filter the data based on some staff, the salaries above the average salary, and some demographic specific information. It means they want to just click on something, open a pop box, write down 2 or 3 things, and just fetch the data. They don't need to write the query. we should prepare that application for them, and they only need to run it. The first thing is that we should find the average salary. After that, we should just add that average salary to the table and just compare the table, then filter. The process is just parameterize the previous question that we solved. Okay, now the first thing is that I'm going to select from just the salaries table, and I would like to find the average salary, just the average salary. This is just a simple average salary that we have. Okay, the next thing is that I'm going to fetch some data from employee table. So I go and select employees. Let's select everything from employees. And then we can make a decision which kind of columns we need to keep. We need gender, we need birth date, and that's it. The HR team demographic group is just the birth date and the gender. So we only need these two columns from the employees table. If I select this, we only have these two columns. Now I'm going to bring the average salary to this table. So I'm going to first make a CT table from the average salary. I say read average salary as, this is the average salary. And here I'm going to push some data on it. But before adding the average salary, I need to first bring the salary. So I go for join, go to the salary, join with salary. Salary should be S, employee should be E, and employer number is equal employer number. One of them is from salary, the other one for employer. One more thing is the salary, so I need salary from salary table. Let's run it to see the result. Okay, this is the result. We have gender, we have birthday, and we have salary. One more column. Now it's time to bring the average salary as the next column to our data. So I go with cross join like the previous questions that we answered. Cross join with average salary, and I would like to call average salary. And here I'm going to bring average salary just here. I just add aliens average salary. This is average salary here. Now if I run it, I select everything and run it, we will have one more column as the average salary for all staff. And one more thing is that I'm going to round this data to look like the salary. Oops, not that one, like this way. Now I run it to have without decimal as an integer number. And the aliens, I can say average salary. That's it. This is the average salary, gender, and birth. Okay, now everything is fine, and we have the table. This table is going to be parameterized. It's going to be some kind of application for HR team. They want to filter this data based on two things. First, year of date of birth, which year the staff was born, and their gender. It means they would like to have two inputs in that application. In the first input, they are going to type year, and the other one is the gender. If they put these two data, they would like to see the data. But first, we should put some filter on our data. The filter is that the salary should be more than the average salary. So I should say where the salary, the S salary, should be more than the round of age salary. This is the first filter. that we would like to have. If I run it now, we only have the data that the salary is more than the average salary. Okay, now data is ready to be parameterized. How we can parameterize this process? We can do it with a sort procedure. Sort procedure in SQL is built for this purpose. For doing the sort procedure, I'm going to, let me put everything down here. First, I'm going to say drop procedure if exists, because I'm going to make sure the sort procedure that I'm gonna make doesn't exist in the database. If it exists, first drop it, and after that build it. Drop procedure if exists, I say HR application. So now I can create the application or the stored procedure. This starts with delimiter and it ends with delimiter. Inside this one, the first thing I'm going to make is create procedure. Create procedure. What's the name of the procedure? Is this. This is the procedure that I'm going to create. It begin and it end. Now, between the begin and end, I can put my query. Where is my query? It is here. We just created. I selected all of them and put between them. Now just make a bit clean. Okay, everything is clean here. And it should end with this section, just like that. We first drop the procedure if it exists. After that, we create the procedure. Then we put everything, all the queries that we make it, inside the begin and with. Inside this, we have one city, and after that, just join table, and with the filter as a where clause. Okay, this is our procedure. If I run this procedure, just let's see what happened. If I run it, the procedure is created. Now, if I refresh, the procedure is here. And if I click on that, I jump to this table and I call the HR application from the database as an employee, and we see the data. But as the query shows, it brings all the data, regardless the year of the staff, the year of date of birth, and the gender. As I said, these two demographic information should be parameterized for HR team. They are going to which year or which gender. So we should put some argument for our application. So I close it. Now here, I can put two arguments. The first one, I'm going to begin P or as a parameterized. The first one is gender, P gender. And the gender is just a text in terms of the data type. So text. And the other one is P. The other one is year or date of birth or year birth. And this is integer. I have two parameters, gender as a text and year birth as an integer. Okay, but how I can involve these parameters in my query? As I said, HR team wants to filter the data. So we should go here on the filter or where section. This is the where clause. The first clause is that the salary should be above. This is the basic for the table. Another one is and. Another one is the gender, or the gender that we have is coming from employee. We forgot to put that. Employer, birth date from employer. The gender should equal P gender, and another filter, let's put it there. Another filter is that year of date of birth or year of date of birth should be equal p birthday. These are two parameters that be involved in the query. The first filter is gender should be matched with the gender that HR team selects, and year of date of birth should be matched with the year birth that HR team selected. Again, I run this query. As you know, we have drop procedure. So if I run everything, this new query is going to replace with the old one. I run it and again refresh. Now again, we have stored procedure here. The application is ready for HR team. How they can use it? They only need to click on that. Two parameters are open. The first one is gender. The second one is year of birth. The gender should be text. They are going to see only for male, and year of birth, for example, they want to see the staff was born on 1963. If they execute, let's see the result. Only for year birth for 1963 and all the gender, and all of them, they have the salary above the average salary. And if I come back to here, the average salary is for everybody. It is regardless of gender. If we want to just modify the process, we can just simply open it and do everything. We can remove one parameter, or we can just put a decimal or anything and then apply it. Okay, now let's go to the last question. The last question is a bit analytical. It says, how has an employee's salary changed over time compared to the previous compensation level? And it should be like parameterized way. In the previous question, I showed you how we can work with stored procedure for parameterize the process. For answering this question, I'm going to use another way, and I'm going to use variable. Variable is working like a stored procedure, but in a different level. Okay, let's see what question says. We should have a list of all employer, their salary, their previous salary, and the next salary. As you know, based on this EDR, in the salary table, every single employee might have more than one record because during several years of working in the company, they have different salaries. They have current salary, previous salaries, and next year's salary or the newer one. We would like to create a table and answer this question. Okay, let's jump to the question. First of all, let me bring the data from the salary table. This is all records from the salary. You can see we have employer number, we have current salary, we have from date, and we have to date. From date and to date shows is the new one or is the old one. Okay, first of all, I'm going to bring name of the staff. So based on the diagram, we should bring the first name and last name and gender from the employers. So I go there and say join with employees on employment number is equal employment number. Employee, and this is salary. Okay, now we can bring the columns that we need. For salary table, we need salary, salary, we need from date, and we need to date. These are the columns that we need from the salary table. But what about the employee? For employee, we need employment number, or even we can bring from the salary because salary table is our base table. So we can have first name, last name, and gender. Gender. All of them are coming from employee. Let's see what we have so far. Just run the query. Okay, now I'm going to first order the data. because if I'm going to work with kind of analytical things based on the changing over the time, I should set or order data based on a time. So I have to say order by from dates because this is my metric and it should be ascending. If I run it, the older date should come first. And I think first I should sort based on employment number, and after that based on date, because first I'm going to have a list of employees like that, and after that, as you can see, the date is coming from the oldest one to the newest one. Okay, data is ready. Now I need to just let me beautify. Okay, just a bit of space. Okay. Okay. Now I'm going to bring some columns. The first column is the previous years. For doing that, I'm going to use a lag condition or the previous one, lag based on the salary. And just because lag is a kind of window function, I should bring the window function here. Window as. We only need to have lag as a window function. So it is a window function, lag, and it should be over the window function that we just created. And we can call it as previous salary. If I run it, just let's see, do we have any error or not? It takes time a bit because we have a bunch of data and it has to calculate the difference of salary. You see, for example, this is staff, just because this is the first row, we don't have the previous one. But for the second one, this is the current salary. But for the previous one, we have the older salary based on a date, and we have the older one. And for the following rows. So this is the previous one. What about the next year? For the next year, it's super easy. I just copy, and we only need to change lag to lead. And this is next salary. And the last one, I would like to make a difference between the current salary and the previous salary to see how is the salary or compensation increased or decreased or no changes. So I would say salary minus lag over window function as I can say change salary. That's it. Now if I run it, okay, we have the previous salary, we have the next year's salary, and we have the change salary. Change salary differences between the previous salary and the current one. For example, the previous salary for this row is 60,000, but current salary is 62,000. So change salary is almost 2,000 for this year and for all employees. You see here, this is for employment number for the different person. Just because this is a totally different person, it means we should partition our data based on the employer. So here, if I go to the window function, I should say partition by employment number. And now we can run the query. Now I scroll down. You see now for this stuff, we have nothing because this is totally new different partition. Now it makes more sense. Now we have to parameterize this question for finance team because finance team only needs to put the employment number. That's it. And they want to see the result. They don't want to modify the code. They just have the employment number. They would like to write down the employment number and see the table. Okay, for doing that, we should first filter the data. So here I can say where employment number, this one, is something. For this, for example, if I put 111, this one, just this staff, I think we should go here. Windows should be the last, yeah. If I filter only for this employment, let's see the result. We only have for this staff. So even we don't need the partition by, but that's fine. But how we can parameterize it? We can go with the stored procedure that I showed you. We can put all of these ones as a stored procedure, as an application, and just open it and type it. And the other way is using the variable. So I go above and put set. I say at sign, I'm going to define a variable. For example, employment number is, for example, anything. And I copy that one and paste it there. Now I'm going to put 10002. That's it. Now if I run the query, let's see, do we have any error? Yeah, we have error where clause. Employment number, oh, we should put sign, that's fine. Now we have the data only for these stuff. If I change it, for example, to another one, 15, just a random one, and run it, we have for this staff, only for this staff, we have previous, current salary, and the next salary, and different things. I can parameterize even the gender, everything. This is another way for parameterizing the queries. In this project, I just tried to show you how SQL is very, very powerful tool for data scientists and data analysts. It's not only about the select query. You can do many things. You can do even the application. You can help the different departments in your company to make more insight in an easier and more efficient ways. Thanks for watching this video. If you want to find the codes that we worked through this project, please see the link below the description of this video. Thanks for watching and see you in the next video.